Hello everyone, welcome to this tutorial about simulation and modelization of solar photovoltaic in MATLAB Simulink. I will provide you with a lot of video about simulation and modeling of photovoltaic in MATLAB Simulink, how you can use the different parts to simulate the PV array, the PV system, and the PV cell in MATLAB Simulink. The first part will be focused on the specific block in MATLAB Simulink, which is the PV array with this picture. This is the PV array block. So if you will understand this block in simulation, you can add a different part to simulate your project. Let's start with a simple presentation of this part. As you know, modeling and simulation of solar photovoltaic generator is a vital phase prior to mount PV system. So you have to simulate your project in different software. You can use, for example, photovoltaic MATLAB Simulink. You can use also PV system. You can use another software. This video will be about the PV array block with this picture. In this video, I will provide you with the response of a lot of questions. The first question is, what is a PV array? The definition, the general definition of the PV array. And the second question, we will see how do I use solar panel in Simulink and how you can create PV array in solar Simulink and how you can parameter this PV array in MATLAB Simulink. And finally, how is PV array is calculated. For example, if you have a specific PV system in your installation and you want to use this one in MATLAB Simulink, how you can parameter this block to be used in this software. Let's start. As you see in this picture, you have a simple simulation of a PV array. This is the input and this is the output of the system. The PV array is this block, and you have another parameters and blocks in your simulation. So let's define firstly the PV array. What is a PV array? In photovoltaic, we can talk about photovoltaic cell, photovoltaic module, photovoltaic panel, and photovoltaic PV array or PV array. The first one is the photovoltaic cell. This is the first generator that can convert sunlight into electricity. If we take a lot of photovoltaic cells in series, we can build a PV module. By connecting different modules in series, we can get a panel. This is a PV panel. This is, for example, these three modules are connected in series to improve the voltage of the PV system. And if you have a lot of PV module connected in series and in parallel also, you can get the PV array or the PV system. Okay, this is the photovoltaic cell. A lot of photovoltaic cells give a module. A lot of modules in series give you a panel, and a lot of panel connected in parallel can get you an array. That means that an array is a lot of panel connected in series and in parallel. Okay, let's discover the PV block, the PV array block in MATLAB Simulink. In MATLAB Simulink, depending on the year of your software, if you are working, for example, with MATLAB Simulink 2022, or MATLAB Simulink 2020, or MATLAB Simulink 2014 or 2015, you can find a specific picture of the PV array. So you can find this one or this one. It's the same. You have the same input and the same output. In both picture, in this one, for example, we have the input, 2 inputs, and 3 outputs. The same is also in the picture left. So how you can create a PV array in MATLAB Simulink, or how you can use the solar panel in Simulink. Let's pass to simulation in real simulation in MATLAB. Let's, for example, create a new folder, new project. This is new project. Click on library browser. Okay, and you can write here PV array and press enter. Okay, this is the PV array block in my side. I'm working with MATLAB Simulink 2022. Let's take this one in my project. And this is the PV array block in my project. Okay. In this block, I have 2 inputs and three outputs. What is the meaning of each port, each terminal in this block? Let's switch to the presentation. Okay. For the port of the PV array block in MATLAB Simulink, we have the first one, the ER input, means the irradiation applied to the panel, solar panels, in watt per square meter. This is the first important parameter in evaluating the performance of solar photovoltaic in a PV system. This is the irradiation. The second one is the temperature of the cells in degrees Celsius. For T4 temperature, control signal defining temperature of cells in degrees Celsius. So for the output, we have 3 outputs. We have M, we have plus, and we have minus. For the M is for the measurement. The output, M output, will give you and provide you with 5 element parameters. The elements are the PV array voltage, the PV array current, the diode current, the irradiance in watt per square meter. It's the same with the value used in the input, and the temperature in degrees Celsius, which is the same with the input F in the temperature. So with this output, we can get 5 parameters in first in one in output. Here, the plus and the minus are the positive terminal of the PV system or your PV array, and the negative terminal of your PV array. Because in the PV generator, in the output, we have a DC current. In the DC current, we have just 2 terminals, positive terminal and negative terminal. Let's switch to this simulation. This is the PV block. This is the input, and this is the output. If you want, for example, to provide a lot of information about the block, click right with your mouse and click help to get some information about the block parameters. MATLAB can provide you a lot of information about this block. So in the library SimSkip, electrical, specialized power system and source, we get the PV array block. This is the electrical module of your PV array. We have the 2 terminal, positive terminal and negative terminal. So you can find a lot of information. This is the PV array block implement an array photovoltaic module. It uses 1 diode PV module. The block allows you to model present PV module from the National Renewable Energy Laboratory. This is a national laboratory in USA. So the InRail that provide the module in MATLAB Simulink. Okay, we will find the IV characteristic and the PV characteristic. So, and also the different parameters of the ports, input and output. And you can find a lot of extra information about the parameter, how you can parameter your PV array. And finally, you can find in the last of the page some example that you can use as simulation. This is prepared simulation. You can click in this one and find a prepared simulation that you can download in your laptop. Okay, let's switch to our simulation. How you can use this parameter in your simulation? Firstly, let's start with the parametering this PV array block. Double click on the block with the left of your mouse, and you can find this window. In this window, we have the first part in the parameters, the array data. So in the array data, you can specify the number of parallel string and the number of serial connected PV module per string. This is the PV panel that we discussed before. This one, PV panel, number of PV module in series. So you can specify the number of module in series, and you can also specify the number of string in parallel, or the number of PV panels in parallel. Okay, this is the part of the module data. If you want, for example, to work with a specific manufacturer, you can find this one in this list. So click in this part, and you can find a lot of manufacturer of PV array. We can, for example, specify any manufacturer. We have a lot of as you want, as your project. For example, let's specify, for example, Trina Solar. This is Trina Solar, for example, with a module of, for example, 340 watts. Okay, 340. It gives us about the maximum power of 213.15 watts peak. The cell per module, 60 cells. The open circuit voltage, the short circuit current, the voltage, the current, the temperature. Okay, in this right part, you can display the IV curve of your PV array. You can of course display the IV curve and the power voltage curve of your PV system. Okay, let's, for example, specify one PV module, for example, one parallel string and one parallel serial connected and one serial connected module. So, means one module in this simulation. Okay, let's click on apply, specify this one. So it gives us the power of the system, the power of one module, and the power of and the voltage, etc. And you can, for example, display a desired curve. In this simulation, we have a lot of selected possibility. So if we click here, you can find one module in 25 degrees Celsius and specify irradiance. Array in 25 degrees Celsius and specify irradiance, array in 1000 watt per square meter and specify temperature. That means that if you select the first one, you can use and we can simulate just one module. If we specify the second one, you can specify one array. If you specify the parameters of one array in 25 degrees Celsius and specified irradiance that we can use, and we can specify the desired value of irradiation. This is for 1000 watts per square meter and desired specified temperature. So let's, for example, simulate for 25 degrees Celsius and specify irradiation. Okay, this is the proposed irradiation in this simulation. You can, for example, specify 1000 for 500 and 100. If you want, for example, to add one value, click and specify the value, for example, 40, and click on plot. Okay, if you click on plot, so the displayed curve are the IV curve and the PV curve. In the IV curve, we have the curve for 25 degrees Celsius and various irradiance. This is for 1000 watts per square meter, 500 watts per square meter, 100 watts per square meter, and 40 watts per square meter as desired. So for 1000 watts per square meter, the current is about 9.45 ampere, and for the voltage is about the open circuit voltage 46.5 volt. This one. If you want, for example, specify for your system, for example, for 10 serial connected module and for 2 string, means that your system is composed of 20 module. So click on apply to apply these parameters. And finally, click on plot to display the IV curve. Okay, for the current is for two module in parallel. It gives you about 18.9 ampere, and for the voltage for 10 module in series, about 465 volts. With this module, of course, you can specify if you want desired module, if you want to work with a specified desired module, user defined, and you can specify, for example, the number of module serial connected, the value of open circuit voltage, the value of short circuit current, etc. And finally, you have to click on apply to display this parameters. And you can, of course, find a lot of parameters about your specification. For example, light generated current, diode saturation current, diode ideality factor parameter, shunt resistance, series resistance. This parameter could be used if you want to simulate large parameter, and if you are working in a specific articles or specific report that you can use in your project. So thank you for watching this video. This will be the first video in this simulation, in this training. I will provide you how you can connect these parameters, this block with different parameters in the next simulation. How you can use this one if you want to simulate complicated simulation. For example, with this one. With this one, we have the input, the irradiance, and the temperature. We have also the block, and you can find the different parameters. This is